Xcode improvements, macros in Swift, and CoreData replacement. The news has already cooled down a bit after WWDC. It's time to take a fresh look at the major changes. In other words, how did the latest Apple keynote affect the engineers? Subscribe to our channel so you won't miss fresh news about iOS and macOS engineering. I'm Serhiy Botenko, an engineer at Clean My Mac, and here we go with the news. Let's skip all the product updates. You might have already read about them all over the media. Instead, I will briefly update you about the key changes that affect our work, as well as about new APIs. We will start with Xcode, a tool where we spend most of the working hours. Here are the 5 most important Xcode 15 updates. Number 1. Xcode is decreased in size even more. If you choose only the macOS SDK, the GMG file weighs just under 3 GB. And unpacked Xcode takes 10 GB. This is half the size of Xcode 14. Number 2. Xcode got improved autocompletion. Once you create a class in an empty file, Xcode will suggest the file name as a name of the class. Number 3. Xcode killed, or rather shell-locked, SwiftGAN, RSwift and other similar tools. Xcode 15 generates type-safe symbols for images and colors from XCSet files. For example, here we have the main use preview image. Xcode generates this variable and updates it when it's renamed or deleted. Number 4. String catalogs. There are some dramatic changes here. Apple has completely changed the format of how translation files are stored. There will be just one file instead of separate files for each language. Therefore, changing the localization key will affect all the languages, so you won't miss any key. There will be also a check in case of missing translations for any language. And if you change the original value, Xcode will mark all translations as needs review. Number 5, last but not least, a new Quick Actions panel is available in the latest Xcode. You can access it by pressing Command-Shift-A. These panels allow you to call any action from menu bar or context menu. For example, you can create a new file or rename a variable. Looks like a bunch of tiny changes, but they might significantly improve your daily work. Let's move to Swift. The most exciting feature is macros, which allows you to eliminate a bunch of boilerplate code. Check out the list of open-source macros via the link in the description below. For example, there is a macro to generate an init with all public variables, so you don't have to update it when you add a new variable, or generate a mock for a class for unit tests. And the second feature is that if-else and switch statements now return a value. Here you would have to write a return for each case. Return fail, return pass, and so on. Now there is no return at all. It's time for SwiftUI. There are new types of animations. The first type is a keyframe animation. First, we create a view that you want to animate, and then we create animations that are applied in parallel. This way, you can create a fairly complex animation, where we move an object, rotate it, and resize it. The second type is phase animation. Unlike the previous animation, we set the phases applied in sequence. First shrink, then spin, grow, and reset. Now elements appear on the screen could be animated too, with a new API in scroll view. Look at this stunning animation. It can be done just by adding a few lines of code. Tons of changes that can save you dozens of code lines are about macros. Instead of observable object protocol, you can use observable macro for the class. It will automatically add the observable object protocol and make all the variables published. I highly recommend you to watch Discover Observation in SwiftUI session to get into it. Swift Data. It's a new data storage framework that replaced CoreData. Now you don't need to create a database scheme. Everything is described in a data model, like your model is your scheme. To make a class available for storage, you need to add the new model macros before the class declaration. To get this data in the SwiftUI, you just need to create a variable with a query macro and set up a sorting if you need some. 2 lines of code and we have a data storage. To be honest, we still need to configure the container. But it is one more line of code. If you don't use SwiftUI, you can get the model's user's fetch descriptor. Take the context from the container, set up a request, and execute it. almost the same as working with NS fetch request from CoreData. And finally, spatial computing and spatial design. I was pretty short on time to fully dive into these sessions, so don't miss the complete review in the upcoming episodes. Today I will recommend you the sessions available on this topic. There are plenty of them, so let's figure out which ones you should start with. The first session is Get Started with Building Apps for Spatial Computing. This is the basis for work. It's about the foundational elements of spatial computing, windows, volumes, and spaces, and how to use it to build a spatial app. The second session is Design for a Spatial User Interface. It's about playing with fonts, colors, and Windows transparency you use to design a perfect interface. And the third session is Design for Spatial Input. It's about designing applications that are user-friendly and easy to use with your eyes and hands. For example, to attract user attention, you should create smooth shapes such as circle or rectangle with rounded corners, squiggles. This trick helps the eye to focus on the center of these shapes, not their edges. And the fourth session is Meet SwiftUI for Spatial Computing. Now that we figure out what to do, we can move on to how to do it. Develop a real app. If you want to read the brief updates, Apple has a page with text descriptions for different topics, such as UIKit, SwiftUI, or Xcode. Check out the link in the description below. And don't forget to hit the subscribe button. See ya in the upcoming episodes.